On today's lecture, you are going to study a very important topic called Coriolis force. Okay, so although this force or this concept is there in your advanced syllabus, it is skipped in most of your coaching classes. Okay, so I have tried my best to explain this topic. If you like it, do mention in the comment section. If you dislike it, then also do mention in the comment section. Okay, and go through the problems once. Okay, after understanding the theory that I have given you in Coriolis forces. In this video only I've explained it in a detailed manner. Okay, so let's start with this question. Okay, what this question is saying is that there is a semicircular ring out here, a semicircular ring. Okay, and this ring is rotating with angular velocity omega. Angular velocity omega. Now in this semicircular ring, there is another ring that is free to slide on this semicircular loop. Okay, a ring kept out here is free to slide on this semicircular loop. Now as the ring rotates, what will happen? The ring will slide up. Now when it comes to equilibrium, that means after sliding for a certain while, it will come to stop. Okay, the question is asking find the angle theta when it comes to stop. So you have to draw the free body diagram of the ring. I'm drawing free body diagram of this ring from the frame of reference of this semicircular ring. So from the frame of reference of this semicircular loop. Okay, so if I draw the free body diagram, okay, downward is mg forces. This out here there would be a centrifugal acceleration, which is equals to m omega square y. Why? Because the frame of reference itself is rotating with angular velocity omega, and there would be normal contact force. And the line of normal contact force would always pass through the center of the circle. Okay. Now I have to find out this angle theta. Now I have to take my component of forces along this line, tangential to the normal and along the normal. So when this ring is in equilibrium, that means it is neither moving in this direction nor moving in this direction. So at equilibrium, the component of m omega square r centrifugal force along this line would be equals to component of mg force along this line, because the net tangential acceleration is equals to 0. Why? Because the ring is neither sliding up or down in tangential direction. So when tangential acceleration is 0, what tangential component of force? Tangential component of force. Okay, now I need to find out the angle. See, if this angle is theta, this line and this line are parallel, and this is the straight line. Okay, so if this angle is theta, this angle will also be theta, parallel lines. Okay, now this line and this line makes a 90-degree angle. So if this is theta, this is nothing but 90 minus theta. So this is 90 minus theta, also written as theta dash. Now this line and this line will make a 90-degree angle. So if this is 90 minus theta, this will be theta out here. Okay, and even out here, if this is theta, this will be 90 minus theta. Why? Because this line and this line are 90-degree. So if this is theta, this is nothing but 90 minus theta. So theta dash. Now, since the net tangential component of force is equals to 0, so can I say m omega square r cos theta? Okay, m omega square r cos theta, or component of this force along this line, minus component of mg force along this line, mg cos theta dash, or mg cos 90 minus theta, or mg sin theta, is equals to 0. Why 0? Because there is no tangential acceleration. Mass into tangential acceleration, and during equilibrium tangential acceleration is equals to 0. Okay, so this entire terms becomes 0. Now if I send this term to the right hand side, what it will become? It will become m omega square r cos theta is equals to mg sin theta. Okay, now can I cancel m and m? I'm cancelling the mass out here. Okay, so tan theta tan theta is equals to how much? Omega square r by g. Now let's focus on this r. What is this r? This r is nothing but the radius of the circular orbit, or the radius of this orbit, no? Radius of the circular orbit in which the ring is rotating, and the ring is rotating in this circular orbit. Okay. Now what is the relation between this small r and the radius of the semicircular ring, or radius of this ring? So if this is small r, can I say capital R sine theta? Capital R sine theta is equals to small r. Okay. Capital R cos theta is nothing but this one, and capital R sine theta is nothing but this one, because this forms a right angle triangle. Okay. And if you replace this small r out here, or tan theta is equals to omega square r. What is the value of r? R sine theta by g. Okay. On tan theta is equals to, or tan theta by sine theta is equals to omega square r by g. Tan theta is nothing but sine theta by cos theta. So 1 by cos theta would be nothing but 1 by cos theta is equals to omega square r by g. See out here. Tan theta is nothing but sine theta by cos theta. Okay. Tan theta is nothing but sine theta by cos theta, and this sine theta would get cancelled. So 1 by cos theta is equals to omega square r by g, or cos theta out here would be g by omega square r. So this is the solution, or the angle theta would be cos inverse g divided by omega square r. Now to understand this question, we need to understand a concept called Coriolis acceleration. Coriolis force. Okay, Coriolis force and acceleration. So start with Coriolis force on the next page. Now what we'll study about is Coriolis force. Coriolis force is nothing but a pseudo force, like centrifugal force. So to understand Coriolis force, first let us look at a video. Okay, this video was from MIT Department of Physics. So here are two guys throwing ball at each other. Okay, and observe the camera. The camera is mounted at ground. Okay, the camera is not rotating. Now what happened? See, they're throwing balls at each other in a straight line. Now they'll start their rotation. Okay, they'll start their rotation. Now see, even though they're throwing the balls at each other in a straight line, the ball deviated from the current path, and we'll see the same motion from overhead view. Okay, see, when the camera is mounted at the top of the ceiling, okay, the bodies tends to rotate, or the people tend to rotate in anti-clockwise direction. Observe one more thing out here. Okay, the camera itself is not rotating, and out here, when the frame started rotating, okay, now observe the ball. Okay, see, this guy threw the ball, and the ball deviated from the straight path. Okay, check this path of the ball. Check this path out. Now observe out here. If I draw the ball out here, okay, and the camera is rotating. Now when the camera is rotating, the camera becomes a non-inertial frame, and every non-inertial frame has two pseudo forces. Sorry, every rotating non-inertial frame has two pseudo forces. The first one is the centrifugal force. Centrifugal force. And the second one is the Coriolis force. Coriolis force. See, if I observe out here, my camera is rotating, no? So any object that the camera sees will experience two forces.
First one is the centrifugal force. Okay, the second one is the Coriolis force. Is that understood? Okay, now according to the camera, okay, from the perspective of camera, the ball was thrown with velocity v. Okay, remember, this velocity v is from the frame of reference from the rotating frame. Okay, out here let me write down note. Okay, every rotating frame, every rotating frame experiences two pseudo forces. The first one is the centrifugal force, the second one is the Coriolis force. Okay, now see, if we take only the account of Coriolis force, okay, the ball out here is thrown with velocity v. The ball should go up and the centrifugal force should pull it back. No, what is the direction of centrifugal force? The direction of centrifugal force is m omega square r, in this direction. Okay, m omega square r, where r is the distance between axis of rotation and the ball. Okay, so this ball was thrown in a straight line. Okay, even if the ball goes in a straight line, the centrifugal force will decrease, fair and fine, but after a while the centrifugal force is never changing the direction, no, from this rotating frame of reference. So they should be, the motion of the ball should be in a straight line, although it may be with different velocity or with changing velocity. We don't know that, it depends upon the centrifugal force, but without any additional force the ball should not deviate. No, the ball should move in a straight line. What is causing this ball to deviate? See, can I say the initial component of velocity along this direction is equals to 0? So therefore there is some acceleration in this direction. There is some acceleration in this direction that is causing the ball to deviate from its current path, or to, there is some acceleration in this direction that is causing the ball to go in this direction, and that acceleration is called Coriolis acceleration. Okay, the force that explains the Coriolis acceleration is nothing but Coriolis force. So first we need to understand the value of Coriolis force. See, if you multiply mass by Coriolis acceleration, it becomes Coriolis force. Now the first thing I need to understand is what are the numericals of Coriolis force. Okay, or how is Coriolis force related? Coriolis force is nothing but minus 2 m into omega cross v. Okay, one more thing, minus 2 m omega cross v. Now what are these? See, minus 2 you already know. M is nothing but the mass of the object the rotating frame is observing. So mass of this ball. Okay, omega. Omega is nothing but the angular velocity of the frame. Omega is nothing but angular velocity of the frame. Of the frame. Okay, and v is nothing but the linear velocity as observed by the rotating frame. That means this v should be observed by the rotating frame. Linear velocity of the object of the object as observed by rotating frame. Rotating frame. So what have I said to up till now? Any rotating frame experiences two forces, the centrifugal force and the Coriolis force. Okay, centrifugal force you already know, m omega square r. Okay, and Coriolis force would be minus 2m omega cross v. Now some more questions, sir. Why haven't we taught Coriolis force? Okay, in circular motion or in another chapter? Because the value of this is little unintuitive to understand, and most of your questions comes from centrifugal forces alone. So whenever you're dealing with circular motion or this kind of chapters, although Coriolis force exists, but you have to ignore those Coriolis force, okay, until and unless asked in the question. Okay, now see one more thing. Coriolis force, does Coriolis force have any direction? Yes. What is the direction of Coriolis force? Omega cross v multiplied by minus. See out here, omega. Omega is a vector that is coming towards you or coming out of the screen. Okay. V is a vector that is going in right hand direction. So if you point these two, okay, you point your thumb across omega and v and index finger across v, you'll get the middle finger, which is the resultant, in upward direction. Okay, and minus of any vector in upward direction is nothing but downward direction. Okay, so Coriolis force, the direction of Coriolis force would be determined by this cross product. Sure. One more thing, take a certain point in a ground. Okay, if you observe clearly, no, according to this rotating camera, this object will move in a circular orbit. Okay, see, this object will move in a circular orbit. Okay, any point in the ground, doesn't have to be track down. Any point in the ground, any point in the ground means you can either track this black dot or this dot, any point. Okay, you'll observe that it is rotating in a circular orbit about this camera with velocity v. Now this v depends upon the omega and r, where r is the distance from axis of rotation, where v is equals to omega into r. This v is equals to omega into capital R. Okay, now see, I have a question out here. Okay, my question was any point in the ground. Okay, let's switch off the video so it will be better to understand. Okay, any point in the ground. Okay. This is my camera that is rotating with angular velocity omega. Any point in the ground rotates in a circle. Okay, with velocity v. Fair and fine. Where v is equals to omega into r, where r is the distance from the axis of rotation. Up till this much I understood. Okay, my confusion out here is, out here, see, this camera, the camera out here is a rotating frame. Okay, so there should be a centrifugal force. The centrifugal force is m omega square r, m omega square r. Okay, so the velocity, okay, the centrifugal force is always perpendicular to the velocity, as in this direction. Achha. The centrifugal force would always be radially outward. Okay, my question is, if the centrifugal force is in this direction and this is our frame of reference, the body according to this frame of reference should be rotating in this direction, no? But unfortunately what is happening, the body is rotating in this direction. So there is another additional pseudo force, okay, that is acting on this direction, and this pseudo force is nothing but Coriolis force that has been explained before. This pseudo force is nothing but Coriolis force. And what was the formula for Coriolis force? F Coriolis is equals to minus 2m omega cross v. Okay, What is the direction of omega? Towards you. What is the direction of v? Upward. So use right hand three finger rule. Omega is towards you, v is upward. So omega cross v is in this direction or in the direction of centrifugal acceleration, and minus of omega cross v should be in opposite direction. So if we analyze the particle out here, no, if you analyze the same particle, this particle out here, I'm drawing this particle out here. Outward force is m omega square r, m omega square capital R, where r is the distance from the axis, and Coriolis force is minus 2m omega into v. Okay, and what was the value of v? The value of v was nothing but omega r. Acha. Minus of 2 omega, see, minus of 2m omega cross v is nothing but omega cross v would be in this direction, and minus of omega cross v would be in this direction. So when I have already applied the vector in this direction, this minus would be of no value. Okay, the Coriolis force in the rightward direction is 2 omega v. And what was the value of v? The value of v was nothing but omega r. Now when you analyze the force, see, this entire value becomes 2 omega 2m omega square r. Okay, so this particle experiences a centrifugal force of m omega square r on the left, and Coriolis force of 2m omega square r on the right. So the net force would be towards right with m omega square r, and that is why this particle keeps rotating in a circular orbit in this direction. Understood the concept of Coriolis force? So Coriolis force always acts on whenever you have rotating frame of reference. Okay, whenever there is rotating frame of reference, there are two pseudo forces. First one is centrifugal force. Centrifugal force is nothing but m omega square r or mv square by r. Okay, in centrifugal force is only dependent upon the rotational velocity of the frame and distance of the particle from the axis of rotation. Okay, these two. Whereas Coriolis force is dependent upon rotational velocity of the frame and velocity of the particle as observed by the frame. Okay, understood? Whenever a rotational frame is there, there are two pseudo forces. First one is centrifugal force, the second one is Coriolis force. Okay, centrifugal force depends upon the angular velocity of the frame and the distance of the particle from the axis of the frame, whereas Coriolis force depends upon angular velocity of the frame and velocity of the particle as observed by the rotating frame. Understood? Now see this question. Okay, the question which applies the concept of Coriolis force. This is earth out here. These are nothing but the latitude lines, the lines of latitude, and these are nothing but the longitude lines. Okay, now the question is saying at latitude is equals to 60 degree, that means this angle is equals to 60 degree, or phi is equals to 60 degree. Okay, a bullet with velocity 900 meter per second, that means this bullet has a velocity of 900 meter per second. Asha, the bullet is fired horizontal, that means which direction will the bullet go? See, if you observe from earth, no, if the bullet is fired horizontal, that means the bullet will go in y axis out here. Okay, so velocity will be in this direction, and the magnitude of velocity is how much? 900 meter per second. So Vy is equals to 900 meter per second. 900 meter per second. Okay. Now at 1 kilometer from the target, that means in this range, 1 kilometer from here. Okay. So this is 1 kilometer. Okay. The question is saying what direction? Achha, in what direction will the bullet hit the target? Achha. So Earth is rotating with angular velocity omega. The angular velocity of Earth is omega. So if I observe from the frame of reference of Earth, what will happen? They will exert a two force. Okay, there are two component of pseudo forces. One is the centrifugal and the another is Coriolis force. Now my question is, in which direction is the centrifugal force and which direction is the Coriolis force? See out here. Let's draw the latitude line properly. This is the latitude line our. This is our latitude line. Now this velocity of 900 meter per second is along y-axis, and this velocity along y-axis will have two components. One along this latitude line and the other perpendicular to the latitude line. Any velocity can be component to three axes, x-axis, y-axis and z-axis. So I must transfer this coordinate system into this coordinate or along the latitude, okay, and perpendicular to the latitude, okay. So this velocity of 900 meter per second, okay, will have two component. One is 900, see, along the latitude, this is 900 cos of whatever this angle is, okay, okay, and the other is perpendicular to the latitude on 900 sine of whatever this angle is, sine of, this is cos of this angle and sine of this angle, okay. Now see this line and this line are parallel to each other. So if this angle is 60°, this angle should also be 60°, no? Okay, so this angle is also 60°. So this angle is nothing but 60°. Okay, now see, this line and this line are 90° to each other. Why? Because in a sphere, any, this is tangent to the sphere and this is normal to the sphere. Why is this line normal to the sphere? Because it passes through the center of the sphere. So in a circle, okay, if one line is tangent, that means this is Vy or 900 meter per second, and the other line passes through the center, okay, that means this line and this line are 90° to each other, okay. So that means this line and y-axis are 90° to each other, okay. So y-axis and this line are 90° to each other. This is 60°. How much is this much angle? 30°. So obviously 30, okay. So out here cos 30, 900 cos 30 and 900 sin 30, 900 sin 30. This much is understood. Now let's make our diagram little bit of cluttered free, okay. I'll be erasing the unnecessary information. So now what is happening? A horizontal velocity of 900 meter per second was component into two components, 900 cos 30 and 900 sin 30. Now see, the velocity of 900 sin 30 will have no Coriolis force. Why? See, because what is the formula for Coriolis force? Coriolis force is equals to minus 2 omega cross V, okay, into M. Now see, the angle between omega vector is nothing but upward. The angle between omega vector and V vector, this component of V vector and this component of omega vector, is nothing but 0. So W into V into sine 0 is 0. So component of, so this velocity will have no Coriolis forces, but it will have some centrifugal forces. Now my question is, what is the direction of centrifugal forces? See, the direction of centrifugal forces will be along this direction. And the direction of Coriolis forces, okay, it will be, the direction of Coriolis forces will only be for this component of velocity, okay. See, this is 900 cos 30, okay, omega vector is upward. The angle between omega vector and 900 cos 30 is nothing but 90°. One of the vector is in this plane, the other vector is in this plane. So the angle between the both vectors is 90°, and sine 90 is nothing but 1. And what is the direction of Coriolis forces? Use your right hand three finger rule. This is the first vector, this is the second vector, the resultant vector, that means first vector, second vector. The resultant vector would be in this direction, and opposite of this direction is nothing but in towards x-axis.
Okay, so towards x-axis. So Coriolis forces would be towards x-axis. This is the direction of Coriolis force. And what is the direction of centrifugal force? The direction of centrifugal force is directly opposite to the direction of this 900 cos 30. Okay, that would be the direction of centrifugal force. Is that fair? Because the earth is rotating around this circular orbit, a particle out here will be rotating around or moving in a circular motion around this orbit. So the direction of centrifugal force would be directly opposite to this 900 cos 30. But in this question, they have asked, but we weren't supposed to, means we ignored the effect of centrifugal forces in this question. Okay, we are only asked to find out the effect of deviation of bullet due to this Coriolis force. Okay, so Coriolis force is in s direction, the velocity is in 900 cos 30. Okay, another component of 900 sin 30. The component of 900 sin 30 will not experience any Coriolis force. This component of velocity will experience a Coriolis force according to this formula, and the velocity and the direction of Coriolis force is in this direction. So what will happen? Okay, there is a direction of acceleration along x-axis. So Coriolis force will have Coriolis acceleration. And my question is, what is the value of Coriolis acceleration? What is the value of acceleration in x-axis? So let's find out. Coriolis force, or Fc, is equals to minus 2 into, what is the value of omega? The omega is nothing but the rotation of earth. And what is the value of V? The value of V is 900 cos 30. Cos 30 can also be written as sin 60, or 900 sin 60. Okay, cos 30 can also be written as sin 30. Sorry, cos 30 can also be written as sin 60. Okay, so this is the value of Coriolis force into mass. The value of Coriolis acceleration would be nothing but force divided by mass, yani 2 into omega into 900 sin 60 into m. This is the force divided by m. So mass and mass will get cancelled. So the value of Coriolis component of acceleration will be this value. This minus represents nothing but the direction of the force. The direction of Coriolis force will be along x-axis or along this direction. Okay, so I'm just taking the magnitude of the forces out there. So the value of acceleration is nothing but 2 omega sin 60. Okay, so if acceleration is acting in this direction, the bullet while traveling in this direction, okay, will face an acceleration in x-axis or this direction. Okay, so after traveling for 1 kilometer, okay, let's, what will be the deviation of the bullet? So let's make this diagram little bit more neat. So the bullet while traveling in y-axis or horizontal with velocity 900 meter per second, okay, will face an acceleration in x-axis, x component. So it will deviate by some amount, no? It will deviate by some amount. The question is asking find the amount it deviated. Okay. So initial x component of velocity is equals to 0. Okay. And final displacement in x-axis is how much? So we need to find out for how much time it traveled in this direction with the acceleration of AC. So time taken to cover 1 kilometer with velocity 900 meter per second. So time taken is nothing but time taken is equals to how much? Distance by time, or distance by speed. Okay, this is the time taken for this bullet, to travel 1 kilometer, and in the same time the bullet will deviate along x-axis with the acceleration of Coriolis acceleration. So deviation is equals to, I'm simply applying the formula, S is equals to ut plus half at square. U is equals to 0. Initial component of velocity along x-axis is equals to 0. Okay. Coriolis component of acceleration is nothing but 2 omega, acha, 900
or velocity into sine phi. See, instead of writing 900 sine 60, I'm writing v sine phi. Okay, into time taken. Time is nothing but distance. Distance divided by speed. Where speed is nothing but v. Speed is nothing but 900. So time taken is nothing but distance, or distance which is 1 kilometer given in the question, divided by v. So deviation or s, this s is nothing but the deviation out here. Or deviation is equals to half. I'm simply writing this formula. Okay, substituting everything in terms of this formula. Half into 2 omega v sine phi into d by v. Okay, v and v would get cancelled, 2 and 2 would get cancelled, or deviation would be equals to omega d into sine phi is equals to omega d sine phi. Okay, omega d sine phi. I made a little bit of silly mistakes out here. Okay, s is equals to ut plus half at square, half at square. So dy v whole square. So this dy v whole square. So it would be d square and one of the v would get cancelled, omega d sine phi by v. So deviation is equals to omega d square by v sine phi, where phi is nothing but this angle which is equals to 60 degree given in the question. The silly mistakes I made out here, s is equals to ut plus half at square, no? So I did not take the square out here. So take the square, make the appropriate square. So our deviation would be omega d square by v sine phi. Now if you put on the value, okay, omega is equals to 2 pi divided by 24 hours, or 24 into 3600. We have to convert the hours into seconds. 2 pi is nothing but the angular velocity. Okay, the earth rotates in 24 hours. So the earth completes 2 pi radians, 2 pi radiations, 24 hours, or 24 into 3600 seconds. Okay, d out here is nothing but the distance it must travel, which is 1 kilometer or 1000 meter. Okay, and v out here is nothing but the velocity, which is 900 meter per second. Okay, if you substitute the values, we'll get deviation, or this much distance while the bullet travels 1 kilometer upward is nothing but around 0.07 meter, which is nearly equals to 7 centimeter, which is equals to 7 centimeter. Understood? In this question, what the question is saying is that there is a disc, a circular disc. Okay, it is rotating about this axis with angular velocity omega. Now out here in this disc, a particle is thrown with certain velocity v, and this particle intends to move in a along the diameter of the disc. Okay, that means some grill or something is kept which is forcing this particle to move along the diameter of the disc. Okay, a groove is kept out here, or groove is made in the disc which is forcing this particle to move along the diameter of the disc. Okay, now the question is asking, find the total force acting on this particle. Okay, so if we change our frame of reference to the disc, okay, from the frame of reference to the disc, there are basically two forces. One is centrifugal and the another is Coriolis. See, the value of centrifugal force m omega square r would be directly opposite to the direction of rotation. Okay, if the body is rotating this side, centrifugal force would be acting this side. What is the direction of Coriolis force? See, F Coriolis. Coriolis force is nothing but minus 2 omega cross v into m. Okay, v is in this direction, omega is towards you. If you use right hand three finger rule, okay, omega towards you, v in this direction. The direction of 2 omega cross v comes in downward direction, and minus of downward direction is nothing but upward direction. So Coriolis force would be in upward direction, and the magnitude is 2 omega v into m. Now see, I'm seeing this disk from the top of the disk. That means where is the gravity force acting? The gravity force is acting inside the plane of paper, okay, and the normal force is acting outside the plane of paper. So gravity force is acting out here. This is the gravity force. Okay. Now see, whatever the velocity was moving inside a groove, no? Otherwise, if the velocity, if you throw any particle, the particle will slightly move towards this side due to Coriolis force. You have seen in the demonstration in the video. So to keep the particle in a straight line, a groove was cut, and that groove was making a normal forces. Okay, see, there is another forces mg. Mg is also being balanced by normal forces. Why? Because if normal forces to balance the mg forces were not there, the particle will fall down or inside the plane of paper. Understood? So the question is asking what is the total force exerted by this plate on this particle. The total force exerted by this plate on this particle is nothing but the combination of these three forces, Coriolis and gravity. Okay, these three particle, okay, these three forces are being balanced by the normal forces or contact forces, not only normal forces, normal plus friction or contact forces by the disk. Okay, because from the outside frame of reference, if you just throw a velocity, suppose no groove was there, okay, it should travel in a straight line if no groove or nothing sort of was there. Okay, but see, from the outside frame of reference, the ball will experience a weird path. Okay, it would go somewhat like this, and it would slightly spiral towards the center. So to make it spiral towards the center, there must be some normal forces. Okay, to find out the total value of normal forces, we observe from the frame of reference of disk. And from the frame of reference of disk, there is a Coriolis forces that is balanced out by the groove of the disk. There is this centrifugal force, okay, that is being balanced out by the friction force from the disk. And there is this mg forces, okay, that is being balanced out by the normal forces that is acting outward from the disk. Understood? So the total forces exerted by the disk is a combination of these three forces when you look from our frame of reference from this disk. Okay, so total force is equals to, see, and these three total force acts in 90 degree to each other, so is nothing but mg square plus 2 omega vm whole square plus m omega square r whole square. Understood this fact, the Coriolis force is being balanced out by the normal force exerted by the grooves on this disc. There is a groove, okay, this groove is making this particle move in a straight path when you observe from our frame of reference. Okay, and from the outside frame of reference, this particle will move in a spiral path towards the center. This mg force is being balanced out the normal reaction from the disk, and this m omega square r, okay, this centrifugal force is nothing but the force balanced out by the friction force from the disk. Okay, so if you put the values of m, which is equals to 50 kg, okay, g is nothing but 9.81 meter per second square. Okay, this value of g should be memorized. Okay, omega is nothing but 6 radians per second. Okay, v is nothing but the velocity of the particle, which is equals to 50 centimeter per second or 0.5 meter per second. You must always use SI unit in calculation to avoid error. Okay, m, mass is already given, velocity of the particle have taken out. Omega square is already given. This r, Now you have to find out the centrifugal force when this particle was 30 meter or 30 centimeter from the center, 30 centimeter from the axis. So R is equals to 0.3 meter. So R is equals to 0.3 meter. Okay, always use those SI unit. Now when you plug in those values, we'll get the force around 8 Newton. Use calculator. See, we'll get the force around 8 Newton.
See, what is happening out here is there is a long rod. Okay, there is a long hollow rod, and this hollow rod is rotating about the axis with angular velocity omega. And inside this hollow rod, there is a ball that is projected with velocity v naught. Okay, so if I see this ball from the frame of reference of this rod, okay, that means this frame of reference is rotating with angular velocity omega. So therefore there will be two forces acting on this ball. The first force is what? The centrifugal force, and centrifugal force is nothing but m omega square x, but x is the distance from the axis. The second force that would be acting on this ball is nothing but the Coriolis force, or F Coriolis, and the force of Coriolis is given by minus 2 omega cross cross v into m. Okay, and what is the direction of 2 omega cross into v? If you use your right hand three finger rule, omega is a vector that is acting out upward, because omega is an axial vector. V is acting towards left, so omega cross v would be acting towards you, or outside the plane of paper. Okay, and minus of any vector outside the plane of paper is nothing but a vector that is inside the plane of paper. So Coriolis forces would be acting inside the plane of paper, and that is nothing but 2 omega v m. Now notice one thing out here. This velocity is what? The velocity in Coriolis force is nothing but the velocity of the ball, or instantaneous velocity of the ball. Now notice one more thing. The ball is initially projected with velocity v naught, but as it goes towards this side, there is an acceleration acting on the ball, or centrifugal acceleration acting on the ball. So this centrifugal acceleration will try to decrease the velocity. So as the ball goes towards left, what will happen? The ball will decrease its velocity. So when the ball decreases its velocity, this component of v will decrease. So when this component of v decreases, what will happen? The Coriolis forces also decreases. And now our question is asking, find the Coriolis force. Okay, find the Coriolis force. Okay, when r is equals to 50 centimeter from the rotation axis. That means when this x is equals to 50 centimeter. Okay, find the Coriolis force. That means when this x is equals to 50 centimeter. So can I use this component of acceleration, or this component of equation? Okay, equation along this line or this axis. Okay, see, there is no component of acceleration or no component of force. There is no component of Coriolis force along this line. The only force acting along this line is nothing but the centrifugal acceleration. So can I write mass into acceleration? Okay, along this line. Along this line. See, I'm not taking a component along, or component of acceleration along the outside the plane of paper or inside the plane of paper. Okay, so mass into acceleration along this line is nothing but, what is the force? M omega square x. So if I omit the x, it will be this value. What is acceleration also written as? V dv by dx is nothing but omega square x. Okay, so out here can I write V dv is equals to omega square x into dx, or v square by 2 is equals to omega square x square by 2 plus some constant. Okay, now in order to find out the value of constant, we must apply boundary condition. What is the boundary condition? At x is equals to 0, that means when the ball was initially at axis, the initial velocity was v naught. See, the initial velocity is v naught at x is equals to 0. So at x is equals to 0, v is equals to v naught. So if we put x is equals to 0 and v is equals to v naught in these two equations, we get the value of constant is equals to v naught square by 2. V naught square by 2. So if I rewrite this entire equation properly, what will happen? V square by 2 is equals to omega square x square by 2 plus v naught square by 2, or v square by 2 minus v naught square. Acha, I don't need to write this equation properly. What I need to do is I need to find out the value of velocity. Why? Because I need to substitute that velocity inside this Coriolis force. Okay, because the question is asking the component of Coriolis force. So if I cancel out the 2, okay, the component of 2 is cancelled out, or v is equals to under root of omega square x square if I square root both hand side. Okay, now see, let me write this little bit neatly. V is equals to under root of omega square x square plus v naught square. Okay, okay, so we have found out the velocity. Now the only job remaining is to substitute this velocity out here. So Coriolis force, F Coriolis is equals to 2 omega into v. V is nothing but under root of omega square x square plus v naught square into m. Okay, now in this question, omega is nothing but 2 radians per second. Okay, this omega and this omega is nothing but 2 radians per second. M is nothing but 0.5. M is 0.5 kg. Okay, we have to find out the value of Coriolis force at x is equals to how much? 50 centimeter. So this x is equals to 50 centimeter. Okay, this x is equals to 50 centimeter, and v naught is nothing but 1 meter per second. V naught is nothing but 1 meter per second. So when you substitute all the values, okay, omega is equals to how much? 2 radians per second. X is equals to 50 centimeter, which is equals to 0.5 meter, and v naught is equals to 1 meter, and mass is equals to how much? Mass is given as, let's see, where is the mass given? Mass is given as 0.5. Mass is given as 0.5 kg. 0.5 kg. See, mass is given as 0.5 kg. Now, if you use calculator, you will find out the value of Coriolis force at radius 50 centimeter, which is equals to, if you use calculator, we will get the value of Coriolis force is equals to 2.8 Newton, or 2.8 Newton.